All right, ladies and gentlemen, so today we're starting Chapter 8, which is going to be a lot of new material. So it also happens to be one of my favorite chapters. So hopefully you guys are going to find it easy, even though it is some new material. As always, the first sign that you don't understand something, you need to get your butt in to see myself or Mr. Bush to get some help and figure this out. So we have a lot of definitions, and then stop me at any point. I will go through, though, and at least describe what they are. So in the last chapter, we dealt with these things called monomials, which is either a number, a constant, a variable, or the product of those. Well, now we're going to get into something called polynomials. And a polynomial is when you have, it's a monomial or the sum of monomials. Knowing that you can also have subtraction signs in there because that just means there's a coefficient of a -1 in front. So now we're going to start, okay, what happens if I have these things listed together? We have two special kinds that we talk about, a binomial, which is the sum of 2, and a trinomial, which is the sum of 3. Hopefully that makes sense. Bi and tri mean 2 and 3. We then talk about something called the degree, and the degree is talking about the exponents. For a monomial, it's the sum of all the exponents. So for example, if I had 5x squared y to the third, my degree would be 5 because of the 2 and the 3. The degree of a polynomial is the greatest degree of any term. So it's the biggest degree of any one little piece. And that's going to be for the whole polynomial then. Standard form is when we write the degrees of the terms from greatest to least. So it would be something like 5, 4, 3, 2, 1 of those terms. And the leading coefficient is the coefficient of the first term. So here you can see this is written in standard form. This one doesn't have a special name. It's a 4 term because I have 1, 2, 3, 4 things. But again, it doesn't have a special term. The highest degree is a 3. So this is a third degree polynomial. I can't spell today. I know, not like any other day, right? Okay, so I would look at the highest. These are written in order from biggest to smallest, 3, 2, 1, and then when you don't see 1, it's a 0, because any number to the 0 power is 1. 7 times 1 is 1, using all those lovely properties. All right, so let's see if we can start putting these in to use here. So I want to know a couple of things. Determine whether each expression is a polynomial. I have to do that first. If it's a polynomial, find the degree and determine whether it's monomial, binomial, or trinomial. Okay, so when I look at this, I have x. So yes, this is a polynomial. Now I want to know, well, what's its degree? So I'm going to look for my exponent. If I don't see one, we know that there's always a little 1 written there from our work in last chapter. So my degree is 1. This is a monomial. There's only one term there. Okay, so that's a monomial. All right, let's try this next one. Now, this might trick you because you're going to look and be like, oh, first of all, let me rephrase that. First, I have to figure out, is it a polynomial? So I have all these are monomials, so yes, this is a, monomial, or a polynomial, because these are all monomials. Then I want to know what's its degree. The degree is the highest exponent of any part, so this is a degree of 2. Then I want to know, is it monomial, binomial, or trinomial? Well, when you look at this, this would actually be a trinomial because these two have the same exponent. Those are really the same kind of term there. So this would be a trinomial. And we'll talk more about that later because I could put those two things together. They're like terms. For letter C, so I need to know, is it a polynomial? Yes, because this and this are both monomials. They're being added together. My highest degree, this is a degree 2 because it's 1 plus 1. This is a degree 2, so the highest would just be 2. This would be a binomial because I have 2 things being put together. Okay, letter D, is it a polynomial? Well, when I look at my exponents, this has an exponent of -4, which really means it's 10 over x to the fourth, right? That, again, was from last chapter. Well, a monomial is the product of numbers and variables. This is not the product. This is the quotient. So this would be no, because this is not a monomial. And if you don't have all monomials, you can't put it together to make a polynomial. Okay, let's try the next part. Write each polynomial in standard form. That means that I want it to go from biggest to smallest. So when I look here, I have an exponent of 2, of 5, and a 1. So this has to come first. It's the biggest. We always take the sign of what's in front. So it's a positive, so it's 4x to the fifth. Next would be 3x squared. It's positive, so I write it as a plus. And then the 7x, it's minus, so I write it as a negative 7. Then this number with the highest degree is your leading coefficient. Okay, let's try another one. So I have a 1, a 0, a 4, and a 3. So the 4 has to come first. I'm going to take the sign of what's in front, so negative 2y to the fourth. Then I need the third, negative 6y to the third. Then I need the 1, it's positive, so it's plus 5y. And then I need the no variable, because it had an exponent of 0. Leading coefficient is negative 2. Okay, hopefully not too bad so far. Today's just kind of more vocabulary than anything else. Let's see what we have on the next page. Find the sum or difference. This is your combining like terms. Okay, that's what this is about. We're combining like terms. We're finding things that match, and we're putting them together. So when I look here, I have a 2x squared, right? This is a trinomial plus another trinomial. So you're just going to match up the parts that go together. Here's an x squared. Here's another x squared. So I'm going to put 2 and negative 4 together, which is going to give me negative 2x squared. Okay, we did this last year in 7th grade, beginning of this year when we did our algebra chapter. Then I have a degree of 1, so 5x. Put that together with my 6, which is going to give me negative 11x. Then I have my constants. Negative 7 and positive 3 is negative 4. So that is the sum, negative 2x squared plus 11x minus 4. Okay, same idea over here, right? So this one also happens to be written in standard form because I went 2, 1, and then 0. So I'm going to start with my biggest exponent just so I can automatically put it into standard form. So here I have a y to the third, and I have another y to the third over here. So y to the third plus 2y to the third is 3y to the third. Then I'm going to look to see, are there any y to the seconds? I have 1 here. I don't have any others. So it just gets copied over. 4y to the second. Okay. Then I have y's. So I have 3y and negative 4y, which is negative 1y, or just minus y. And then my constants, I have a negative 5 and a positive 8, which gives me positive 3. So this would be a third degree polynomial. It is not a monomial, binomial, or trinomial. It's just a polynomial with a leading coefficient of 3. All right. Now I have a minus. Well, this again, we're putting together distributive property and are combining like terms. So I have to first take and distribute a negative 1 to every single thing in here. So 3 minus 2x plus 2x squared. I'm going to do that first. Then I'm going to have minus 4x plus 5 minus 3x squared. It's basically just changing the signs of everything that's in the parentheses after it, because it's a negative 1. Now I'm going to put things together. I'm going to put it in standard form because I want you to get used to that. So I'm going to start with squared is my biggest. So I have 2x squared, negative 3x squared. So that's negative x squared. If you want to put the 1 in front of it, fine, but I'm hoping you can get away from doing that. Then I have a negative 2x and a negative 4x. Put those together, you get negative 6x. And then I have a 3 and a 5, which gives me 8. So here I have a trinomial, power degree of 2, leading coefficient negative 1. Same idea here. I have to take and multiply through by a -1. So I'm going to copy the first part over. And this is going to give me -3p to the third minus 2 plus 9p. So I have p to the thirds. I'm going to put those together first. So I have 4 and minus 3, so that's a +1, so p to the third. I don't have any squares, so you just skip that part. Then I have 7p and 9p, which gives me 16p. And then I have my constants, -8 and -2 is -10. So this is also a trinomial, but this is a degree 3, and my leading coefficient is 1. All right, what else do we got? The equation, P equals 7m plus 137 and C equals 4m plus 78 represent the number of cell phones, P, and digital cameras, C, sold in M months at the electronics store. Write an equation for the total monthly sales of phones and cameras. So total means that I want to add those together. All right, so T, total number of sales, is really, I'm going to write this out here, is phones plus cameras. Well, I know the phones and the cameras are like this. So phones was 7m plus 137, cameras 4m plus 78. Now I'm going to just simplify that because it looks a little messy. So I can put together my m's. 7 and 4 is 11m. 137 and 78. Of course, I don't have my calculator with me. Hoping it's 215, and I know you guys will let me know if it's not. Then predict the number of phones and cameras sold in 10 months. Not sure how that's the cost. Oh, total monthly sales. I'm sorry. It's the number of cameras. I was thinking it was talking about cost. Sorry. So now we're just going to put this in for M, because M is representing the months. So 11 times 10 plus 215. So my total, 11 times 10 is 110, plus 215 should give me 325 total cameras and cell phones. You could have put the 10 in to each of these and then added them together. That would have worked as well. Is that it? Yeah, that's it. Excellent. So any questions, as always, bring them to class, and I hope you have a good night.